For this week, obviously, the main focus is on public opinion and polling, but this brings in some issues about how polling data are used, how they're measured, and ultimately it comes down to a case of statistics. Now, I'm probably the last person in the world to be giving a talk on statistics uh, because, as my uh, statistics professor in college in grad school would be happy to tell you. Um, I'm not the world's greatest statistician. Basically, about midway through the course, he told me, "Boy, you're going down." Okay, but there are some issues, less with number crunching itself, but with how we use either polling data, which, as I say, are a form of statistics, or statistics themselves. And I'd like to hit a couple points on this that I think are useful. And no, I'm not going to give you a statistics lecture with a whiteboard in the back with formulas, mostly because I would be totally unable to. Okay, but throughout every time you open a newspaper, read a magazine, watch news, watch a streaming source, people are going to be coming up with, wow, these are the statistics that support us. Be very, very careful with this because there's a lot that can go wrong with this. And statistics, can be misused because numbers look real, but it all depends on how you come up with the numbers and what you do with them. There's an old saying that there are three things in life: lies, damned lies, and statistics. And you will see this in your everyday lives as you go through. So a couple issues here, and I'm going to sort of fold in some of the polling stuff that was talked about in your readings. The first issue, though, is sample size and how you get the samples. Okay, and this is a huge issue. Now, if you are sitting around your workplace or sitting around a bar or whatever, and you do a poll of, for instance, who's going to vote for, or what presidential candidate are people going to vote for, and you get 10 people, and then you try to go, well, these 10 people say they're going to vote for X. Um, I wouldn't rely upon that too much in terms of the actual election. Okay. Sample size is huge, and how you get your samples is huge. And this certainly showed up, as I say, in the most recent elections because they, although the overall numbers came out kind of okay for the pollsters with a margin of error, which people forget about. Yeah, uh, some of the some of the results they're still trying to unpack uh, because I think they took their sample sizes a little off. And this is a big issue now for collecting any sort of data from the public, that people just aren't cooperating anymore. When I was a young lad back in the dark ages, everybody had their landline telephone. I'm guessing that many of you have never seen a landline telephone. Okay. But this made it easy for pollsters because they could essentially go to a phone book. Again, something you probably have never seen. Uh, but they would and essentially select random numbers. They'd call, expect probably 75% of the people not to respond. But then the 25% they selected at random would, and they'd come up with what they considered a decent sample size. Now it just it's virtually impossible with cell phones, with smartphones, because people either ignore it or they have no way of getting the numbers themselves. So this becomes really important, both the sample size and how representative it is. Okay, um, because for instance, you can have a and again, I'll use presidential elections because it's fairly straightforward. You could have a huge sample size from the state of Florida, let's say. But what's that going to tell you about national? Okay. Uh, and that becomes, as I say, it's become a real issue. Now, as I say, this last election, in terms of raw numbers for the polling, um, they came up okay within, as I say, margin of error. And that's another important term that you always keep in mind. Whenever you look at something like polling data or other statistics, look for the margin of error. There are fancier terms for this, but that's really what it comes down to. In other words, we think 40% of the people think this. Always as you go down, though, and a lot of times this is going to be sort of buried, what's the margin of error? Because if it's 10% or 11%, even more importantly, that 40% could actually be 51%, or it could be 29%. I think I got the math right there, maybe. And that's a huge difference. On the other hand, if it's a 1 or 2 or 3% margin of error, it's going to be a lot closer to reality. So always keep that in mind. Okay, when you're crunching the numbers or when you're looking at the numbers. The other issue I want to bring up, uh, that's kind of a particular issue for me, is the issue of correlation versus causation. And so many people get this wrong. And as I say, this is one that drives me crazy, even as a non-statistics type. In fact, my wife actually got me a T-shirt about it. And let me give you an example that sounds silly, but I swear it's not that off from other things I've seen. Now, if you graph for each year, do sort of a bell graph, we call it, from January through December, you will find that when there are the largest number of shark attacks, there are also the largest number of people eating ice cream. It's true. Absolutely accurate. It When people eat a lot of ice cream, it peaks. At the same time, there's a lot of shark attacks. Therefore, eating ice cream causes shark attacks. I'll let you think about that for a minute. Okay. Now you're going to go through that very quickly and go, okay, there's something wrong here. But I've seen, honestly, some studies that were almost that bad when you start digging them out. Just because something happens at the same time does not mean it causes something else. Now, there's also the other issue is, even if there might be some causation, which way does it go? Okay. If you see a strong connection between A and B, well, does A cause B or does B cause A? Again, something people really screw up a lot. And so that's sort of my preaching on this. Be careful when you're reading stuff or viewing stuff that uses numbers. It might be completely accurate, might be very valuable. On the other hand, it could be a load of garbage. So keep this in mind as you're going through this. One thing honestly, I do suggest, although I hate statistics, well, more accurately, statistics hates me. But as you're going through this program or any other program, try to get some course that at least deals somewhat with statistics, because we use them all the time. They're misused all the time, and they actually are important and they're useful in trying to understand the world. So as grim as statistics courses can be, they're worth doing. Okay, no matter what your major, because they will give you a better understanding of the world. Okay, so thank you and charge on.